Hi, welcome to Why Your Site is Slow. My name is Steve Persch. I'm an agency and community engineer at Pantheon. So I come from a background of developing primarily Drupal sites as well as some WordPress sites with agencies as a freelance developer, building all kinds of sites. Now at Pantheon, I work with agencies either new to Pantheon, standardizing on Pantheon, both training agencies on our tools as well as bringing feedback to the internal team at Pantheon. You can find me online as stevector on Twitter, Drupal.org, GitHub. You can also find me as Drupal Haikus on Twitter, though that account isn't all that active these days. So today we'll be talking about that situation you run into when you're making a website. I've been in this situation. I'm making a website. Everything seems to be going okay. We're getting close to launch. The site is coming together. It's doing everything it's supposed to do from a functionality perspective. And then I hear that there's a problem. We're so close to launch. We're a day before launch. We're a week before launch. Maybe we've just launched. But the client says the website is slow. Who's been in that situation where the client says, hey, everything's working good, you've got all the features, but it's just kind of slow, so could you make it fast now? Now that the site is entirely done, could you just make it fast? Because we like everything else, but it's just not fast enough. And this is kind of the reaction that I have. Like, there's not much to be done at that point, other than throw up your hands and say, well, I don't know. The site's done, but I guess it's not fast enough. So when we talk about what reasons a website could have for being slow, let's talk about what a website does in the first place. Often when discussing performance, it's very tempting to get into the latest and greatest cutting edge technologies for performance. I find it very helpful to reset with a basic understanding of what websites are doing in the first place. So websites are sending responses from servers over a network to be interpreted by a browser. Fundamentally, that's what's been happening with websites for 20 years. That's what's happening now, even as they get more and more complex. At the basic level, we still have servers talking over a network to clients. So when we talk about speed, we can isolate those areas. We can talk about the server side, we can talk about the client side, and that's what I'll be focusing on today. We could have a whole discussion just about that network level as well, but I'll be focusing primarily on server side and client side. And as much as possible, I'll be trying to highlight the underlying why. So I'll touch on a bunch of technical issues, and as much as possible, I'll try and highlight why an issue may be difficult on the technical perspective, and often the answer has to do with the people involved, with the organizations involved. So more abstractly, what a website is doing is having a conversation with the client. We can call these browsers that we're interacting with the clients of our website. And I highlight the word client because that's often what we're working with as web developers. We need to have conversations with our clients. Our websites need to inform the world about the organization at hand. So if you are building a site for a nonprofit organization, if you're building a site for a company that sells stuff both in the physical world and online, you'll find that the issues, the problems that the organization has in the real world will manifest themselves on the website. If that nonprofit organization has a difficult time explaining in the physical world what that nonprofit does, it's going to have a hard time figuring out how to explain what it does on its website. If a store has a difficult time selling goods in the physical world, if that checkout process is inefficient, if it's slow, there's a good chance that the checkout process on the website is going to be inefficient and slow as well. So let's jump into the server side. So again, we have this top level problem of the website is too slow. We have to ask, why is the website too slow? Maybe the responses from the server are not fast enough. So why is the server not responding with HTML fast enough? Well, the Web 1.0 answer to that question was probably something like, there's a limit to how fast a .html file can be read off of a hard disk. This is probably not your limitation right now. We're at a Drupal camp, so we're not serving .html files off of a spinning hard disk, but I find it helpful to remember where we're coming from on the history of the web, what the fundamental expectations are for most browsers. Most browsers are expecting to be given an HTML document that they then parse and understand. It doesn't matter to them exactly how that HTML document is generated. The browsers, the clients, simply expect a comprehensible HTML document to be delivered. So the answer these days as to why is this HTML response not coming fast enough, why isn't it immediately ready within 10 milliseconds or less, well, the URL may not be in Varnish. So when I talk about Varnish, that's just one specific type of reverse proxy cache. So the basic idea here is that when a client, when a browser is asking the server, give me this HTML page, I want your home page, I want /about, that is an HTML page that your website should have prepared. That's a question you should be able to answer quickly as a website. Tell me about yourself. You shouldn't have to go to Drupal every single time someone says, tell me about yourself, and have Drupal prepare that page from scratch. That's something that can live in Varnish. So this is a basic diagram for the Varnish website. A client is asking your server infrastructure, tell me about /about. If that request is in Varnish, Varnish can immediately send it back. So if someone has recently asked for the /about page, Varnish can immediately send it back without ever talking to Drupal living deeper in the server. If you're going to /node123 and node123 hasn't been visited recently, or you're visiting as a logged-in user, that complicates things. Perhaps Varnish does have to go all the way to the server in order to prepare a response by bootstrapping Drupal. So if the HTML response is too slow, maybe the requested URL is not in Varnish. So why is the requested URL not in Varnish? It has to do with the HTTP headers involved. This is the metadata about the request that's getting sent back. What I have here is a screenshot of Pantheon's Varnish checking tool. This is just a way to debug whether or not Varnish is working on your Pantheon site. But the concepts are the same regardless of where your caching layer is living. So basically what we have here is a table showing the metadata being sent along with this page. We can see that this page has an age of 6 minutes, 26 seconds. The main thing that I want to point out here is the cache control header. So Drupal, when it generated this response in the first place, told Varnish and anything else living out in front like your browser, this page is publicly cacheable, meaning you can cache this thing and serve it to anyone out in the public, and you can cache it for up to 900 seconds. So this system of using metadata in the form of HTTP headers is how Varnish determines, can I cache this and for how long? And on the Drupal side, this basically maps to this caching element that you have in core. How long can we cache pages for anonymous users, for the general public? In this case, I think by default it's just set to 15 minutes. So let's take another crack at that question of why is the website too slow? Why is the server responding with HTML too slowly? The requested URL is not in Varnish. Maybe we have bad or limited HTTP headers. And so Varnish is getting purged frequently. One of the problems we have with caching with Varnish, especially in Drupal 6 and Drupal 7, is that it's difficult to know exactly what was used on a page. So if you have /news and that has 10 of the latest news nodes, the next time a news node gets published, it's difficult to know. Do we need to purge /news because we just created a new news node, or maybe we saved a news node, and it's hard to know all the places that node is used? So it's common practice for a lot of high traffic sites to just purge tons and tons of URLs every time a node is added or saved, because there's limited metadata. It's difficult to know where all those nodes were used. And this is something that's getting solved in Drupal 8. So if we don't know where a node is used, it's because we don't have a good enough definition of our problem space, a good enough definition of where things are being used. So probably not Albert Einstein, but it gets attributed to Albert Einstein a whole lot. If you only have an hour to save the world, you've got to spend the bulk of your time defining your problem. So when it comes to caching, our problem is defining what assets are being used. So if Varnish can't cache pages reliably, it's because we have poor page-level metadata. If we have poor page-level metadata, if we don't know what nodes and what elements are used within our page, it's because we have poor metadata at the block level or at the views level. So in Drupal 8, we have this new concept of cache metadata. It was kind of present in Drupal 7, but in Drupal 8, it's extremely robust. So imagine an e-commerce site. You've got your main page content that varies by user role, varies by URL. And you have that shopping cart. That shopping cart has to be personalized for every single person using the site. Drupal 8 just has a much more robust way of identifying this block here in the top corner depends on the specific user. Everything else varies by role. So everything else on the page in green you can cache by role, serve it the same to everybody with that role, but this one block in the top, that has to vary per user. When we have this kind of metadata available at the block level, we can be much more robust about the way we do caching at the page level. We can bubble up this kind of information to that page level so Varnish knows what's cacheable and what's not. So I think of this as a revisiting of that chunks versus blobs conversation we had in the Drupal community a couple of years ago around fielded data versus giant body fields that were poorly defined, that had unknown elements inside of the body field. With cache metadata, we have just a much better way of defining what is being used inside of what blocks. So cache tags are the data dependencies, basically what nodes are getting used inside. Cache contexts, does this block depend on the user role? Like what are the global variables getting taken into account, and how long could we cache something for? Can we cache that shopping cart for 0 seconds? Can we cache a shopping cart for 10 seconds? It's up to you as the developer to figure that out. So this is implemented at the level of render arrays. Render arrays have been around in Drupal since Drupal 7, I think, and they're very present still in Drupal 8. And what we're building on is this system of a cache key where you simply set this render array depends on node 1, 2, 3, or this render array depends on the user permissions, basically what is the role of the user signed in, or you can define this render array could be cached permanently. It has no lifetime. You can cache it forever as long as node 1, 2, 3 doesn't change, or as long as the user permissions don't change. So when it comes to Drupal 8, the message from Wim Leers, one of the main developers of this cache systems, he says if you're rendering something, you have to think about how long can I cache this? What are the rules around caching? If you're rendering something in HTML, you have to think about what are the caching rules around this. So let's take another crack at that question of the HTML response is too slow. Perhaps the HTML response is too slow. It's not in Varnish because there is no Varnish at all. Why wouldn't a site have Varnish or something like it? Maybe it's running on a custom internal infrastructure, and the people who have set up that infrastructure don't have the expertise to set up Varnish. And the reason that they don't have the expertise, or the reason that it's running on internal servers in the first place, has to do with the internal politics of the organization. You can find this in the university use case a lot, where there's basically a turf war over who owns the website, and sometimes technical decisions get made that aren't in the best interest of the site. So the question that I like to ask is, at what number of sites is it cost effective to manage your own Varnish config? This is a somewhat rhetorical question. I don't have an exact number in mind. But if I know that if I'm responsible for only one site, I don't want to set up Varnish myself. I don't know how to set up Varnish. But I'm glad that I work at Pantheon with people who do know how to set up Varnish. We've got over 130,000 sites. We know at that number of sites we do need people who understand Varnish, but somewhere between one site and 130,000 sites, it becomes sensible to manage your own Varnish configuration, I think. So really the key question here, though, is I think, what questions or what decisions can you make that will make your site faster and your team faster? I think you make both your site faster and your team faster by letting someone else handle Varnish for you. That's a decision that you can make that will take stuff off your plate as a development team. It'll also make your site faster because it will just work. That won't be the case as we get into other topics here. There will be other topics where you have to make a trade-off between, am I willing to make my team a little bit slower, spend more time with my development team in order to make the site faster, or vice versa? Am I willing to make the site a little bit slower so that my team can move a little bit faster? So let's take a new look at that question of why is the site responding slowly. So sometimes requests do have to get all the way to Drupal. Varnish isn't going to be able to do everything for us. Sometimes Drupal does need to generate a brand new page, and when it does, it might take 3 seconds, 4 seconds, 5 seconds, 10 seconds, and that's much too long for someone to wait for a page to be generated. So why would Drupal be responding too slowly? If you just ask that question in the abstract, you could get all kinds of answers. Someone could tell you that there are too many modules being loaded, and the modules have way too many files, way too much PHP is being loaded, you have way too many queries, or maybe there are queries that are particularly slow, maybe there's too much memory being used, maybe you're loading too many nodes on the given page, maybe too many functions are being called, maybe too many calls to the same function. It's difficult to even know where to start. So if Drupal is responding slowly, let's start first with this potential answer of there are too many queries in place. Well, why are there too many queries on a given page? Maybe we don't know. I certainly have run into that situation where there are too many queries being run on a page, and I don't even know why. I didn't even know that there were too many queries until someone said, that page seems to be kind of slow. Can you check it out? In Drupal 8, we have this new web profiler bar. I think it is available in Drupal 7 as well, but it's a relatively new addition. It comes from the Symfony space, and it can tell us exactly how many queries are being run on every single page. So if you turn this debug bar on, you're going to get all kinds of performance-related metadata about this page request. So we can see this page had only 80 queries. Not bad. But if you're on the home page and you see 1,000 queries being run, that's something that should stand out to you as a developer. So if the first question is, why is the site slow? Too many queries. You need to even know how many queries are being run before you can ask, is this too many, or is this a good number of queries being run? One tool we've just made available on Pantheon for all sites is New Relic Pro. This is a great way to give you insight into the performance metrics on the server side. How much time is being spent preparing each page? How much time is being spent in views module? How much time is being spent in token module? Without even having the statistics available, you can't begin to address the performance problems that you have. Let's take another more specific look at this question of too many queries. Maybe too many nodes are being loaded from the database. How do you address that problem? So Redis and Entity Cache module are a way to reduce the impact of loading a high number of nodes or really any PHP objects. So Redis is an object cache. It allows you to deal with those PHP objects that might get loaded over and over again on your site. If you're loading node 1, 2, 3 a bunch of times, you can pair Redis with Entity Cache module and reduce the impact of loading those nodes. The name of the game across the board with performance is getting to as specific of an answer as possible as to what is really happening. So if you can get to the specific answer of we're loading 20 nodes, and some of those nodes have field collections, and each field collection is its own entity object, that can really slow down a page. But if you know that's happening, then you can add tools to address those specific issues. Maybe it's not too many queries, but it's one really slow query. And a lot of our queries as Drupal developers come from the views module. Views module is a leaky abstraction. A couple of years ago, Jeff Eaton, a prominent Drupal developer at Lullabot, wrote a great blog post about WYSIWYGs as a leaky abstraction. What he meant was that WYSIWYGs are an abstraction on top of HTML. If you're using a WYSIWYG, and it's a good WYSIWYG, you don't have to think too deeply about the HTML being produced. You can make things bold, you can use bulleted lists, you can add block quotes, and you as the person using the WYSIWYG don't necessarily need to think too much about the HTML being created. Unless the WYSIWYG starts breaking, or unless it starts doing things you don't expect. And then suddenly you're worrying about the HTML being produced by the WYSIWYG. And that's almost worse than having no WYSIWYG at all. The same thing is true with Views module. Views module lets us not worry directly about the queries that we're producing. I know that as a developer, I've gotten worse and worse at writing my own custom SQL queries the more I use Views, because I simply don't have to do it. Before I used Drupal, I was proficient in thinking about joins and mentally modeling all the tables that I was connecting up. Once I started thinking in terms of views, I stopped thinking about queries directly, which is fine as long as it works. So what I strongly recommend is turning on the debugging information in the use module. Because you might add a filter, or you might add a join that takes your query from executing in 1 millisecond or 2 milliseconds to executing in 200 milliseconds. You really can add just one more join that destroys the performance of a view. And if you don't even have the stats available, it's hard to know where is this slowness coming from, because this is loading up in the Drupal administrative user interface. If the views UI feels slow, it may be hard to know. Does this feel slow because the query is suddenly taking longer? Or does this just feel slow because lots of places in the Drupal administrative experience can feel slow? So maybe it's not too many queries. Maybe it's one really slow query. Maybe we have one really slow query because we genuinely have one really complex requirement. Staying on that topic, maybe we have one really complex requirement because the requirement hasn't truly been defined. So let's take that example of related news. It's a common feature request on auto sites. If you have a news content type, you may have a sidebar block that's supposed to be related news. And if you can explain in English to one another on a team what related news is supposed to mean, if you can say we have one primary vocabulary on our site, and each news node is tagged in one and only one primary taxonomy term, and the related news list is just a list of other nodes tagged in that one and only one term, sorted by date. If you can explain that clearly, concisely, you're going to be able to query for it quickly. You're going to be able to take that conversation that you can have quickly as people and make it a quick conversation between the server and the browser. But if it takes you 15 minutes to figure out, wait, what was related news really supposed to mean? And is related news different from related blog posts? Because for related news, we are supposed to take into account this different vocabulary, but for related blog posts, we're supposed to take into account the blog author, and we're supposed to take into account the day of the week and all these other things. If it takes you that long to just figure out what this requirements are supposed to mean, it's going to take the query a long time to serve the request. It's going to take the browser a longer amount of time to understand the conversation it's having with the server. So another look at this question of why is Drupal responding too slowly? A common answer you'll get is too many modules. Is it possible to have too many modules? Yeah, probably. Who here has worked on a site that's had over 200 modules installed? What about over 300 modules installed? Anyone? All right, between 200 and 300, that's still high. Drush Site Audit will start complaining past 150 modules. Now, a lot of modules can slow down your site. However, I personally don't think the number of modules is the thing to worry about. I think the thing to worry about is overlapping and duplicate modules. I think this is a much worse concern. Do you have display suite and panels both taking control of your view modes? Is display suite being used for the teaser of blog posts and panels being used for the teaser of news nodes? If so, that suggests to me that your developers aren't talking to one another, that they don't have a sense of the decisions that have been made over the history of the project. And if your developers aren't talking with one another, if they don't have a sense of what modules are being used and why, that's a leading indicator of a bunch of other problems. So yeah, it's one more module. Yes, it's one more set of hooks that get loaded and run. But it's much more likely that there are all kinds of other problems on the site, and the too many modules problem is just the easiest one to spot. So if there's a lack of clarity, a lack of history among your team, you'll run into problems across the board. So can you treat slow like a bug? So if your team is well organized, you'll have a systematic way of addressing bugs. Do you have tests for your module's functionality? If you're testing the functionality you're building, there's a good chance you've got a decent understanding of we chose display suite over panels because, and it's somewhat addressed in these tests that we've written. Can you look through your Git history and find out, oh, we added display suite on this date at this time, and because our Git commit message references a project management ticket, I can go and look in Jira and see, oh, we had this conversation, we picked display suite because XYZ, all right, I'll keep using display suite. Cool. Do you have developer documentation just explaining you're a developer on this project, we use these modules in this way? So I think ultimately, if your server isn't responding quickly enough, if it's responding slowly, there's a good chance that slow was never defined up front. So why might slow not have been defined up front. I think there's a good chance that the team is struggling to define requirements in advance across the board. As a team of developers building a website, along with your project managers, along with your stakeholders, you should be defining the user personas. Who's going to use this site? What are the acceptance criteria? How are we going to know when we're done with our functionality? What behavior do we really expect from this site? How are we going to test this site? How do you know if your site is secure? Is it accessible? Does it behave as expected? Who uses it? And how fast should it execute? I think these are questions that you should be addressing all throughout your process. I've certainly seen projects where there's an expectation that we're going to build it all, and then at the end we'll have a 2-week sprint where we turn caching layers on, we'll make it fast, and we'll cross our fingers and we'll hope that works. I don't think that would be a good strategy for security. I don't think it would be a good idea to assume we're going to write insecure code, but we're going to get the site to a point where it basically works, but we know it's insecure, and then in the last 2 weeks we're going to make it secure. Or if we're going to write our HTML in a completely inaccessible way, but it's going to look good, it'll look visually like the designs, and then in the last 2 weeks we'll take care of all the accessibility problems. Or maybe the site does close to what the behavior is supposed to do, but maybe not quite, but we'll just test it with some real users in the last 2 weeks and hope we can figure it out. I don't think you would do that with any of those first 3 things. I don't think you should do that with performance either. I think it's very risky to think you can just fix performance problems at the very end. So that's the server side. I'm now going to jump to the client side of things. So what we're looking at here is the Chrome developer tools for the Drupal.org homepage. So what's on the agenda of that HTML document? So the server has prepared an HTML document. It's sent that HTML document to the browser, to the client. The client now parses the HTML document, and that's the agenda for the meeting that the server is going to have with the client. The HTML document says, in order to understand this conversation that we're going to have via this HTML document, you're going to need to download all these assets. And ideally, those assets are being listed in appropriate places. So in the case of Drupal.org, it's saying to understand this response, to understand this conversation we're going to have, you're going to need to download these CSS files, you're going to need to download these JavaScript files, you're going to need to download these image files. And what we're getting here is a timeline showing how long it's taking the client to understand this conversation. We can see the client was left waiting for a significant number of milliseconds. Because I was logged into Drupal.org, Drupal.org did have to go all the way to Drupal itself, prepare a response that took a significant amount of time, almost an entire second. The client was left waiting for almost a second, which isn't terrible. It's not 10 seconds. So it's very tempting to get hooked into these numbers. Sitespeed.io is a tool that I've been using recently. It gives you a nice overview and in red, yellow, and green. What are the stats? What are the front-end performance stats related to this site? I find it very tempting to get focused in on these numbers and try and make all the numbers smaller. Like if I sometimes get brought into sites and I hear the site is slow, let's make it faster. Run a profiler like Sitespeed.io, Google PageSpeed, see what the stats are, and think, okay, we just need to make all these smaller, and the site will be faster. Well, that's one way of looking at it. So if your problem is the front end is too slow, your first answer may be the CSS is taking too long to load. So the site has too much CSS. And you can come to the unhelpful conclusion that the website is fat. So Mark Drummond, a prominent Drupal developer, here wrote a helpful blog post pointing out that this language doesn't do us any good. This language actively excludes members of our community, and it gets us focused on the wrong thing. This is not a helpful way to look at front-end performance. So if the CSS is taking too long to load, if the site has too much CSS, maybe there are unused CSS rules. Why might you have unused CSS rules? Maybe because we're afraid to edit our CSS. I've certainly been in this situation. I've gotten added onto a project, I get a ticket saying, you need to work on this new feature, you're going to need to edit some CSS, so I open up the CSS document, I go down to the bottom, and I think, okay, maybe if I just write really specific CSS rules, I'll touch just the area that I'm supposed to, and I won't break anything else, and I've made the CSS document a little bit bigger, much more complex. I've added really specific CSS selectors, and I've made the site slower because I'm afraid to edit the CSS. A tool like Wraith, which is a screenshotting tool, there are a bunch of these, they can give you more confidence in editing your CSS, more confidence in deleting potentially unused CSS rules. Because if you're afraid, as I often have been, that I'm going to break something unintentionally by editing CSS, Wraith and these other screenshotting tools can give you confidence to move forward, to make major CSS edits. So again, with the front end in particular, it's very tempting to get focused on the latest and greatest in aggregation, the latest and greatest in terms of packaging CSS and JavaScript. That's a lot more exciting, certainly to me as a developer, than the slow, difficult work of looking through the CSS that you may have written over the last 2 years and asking yourself, do I still need this CSS? Can I get rid of this? I'm not certain if this CSS file is actually getting used anymore because we edited the template, so maybe these CSS classes aren't even here anymore. So the next question is, do you know where your CSS or JavaScript is coming from? So in the Drupal 6 and Drupal 7 era, it was very common to add CSS and JavaScript and hook in it, adding CSS and JavaScript files to every single page. I know I did this a bunch. One of the problems with this is if you use hook init to add CSS or JavaScript files to your page, you might be adding it to every single page. What if this JavaScript file is only meant to be used on the front end? The way I've written it here, this JavaScript file is going to get added even to administrative pages, making administrative pages that much slower. When was the last time I actually looked at this JavaScript file? Is this JavaScript file still even being used? I don't know, but if I add it to the page via hook init like this, it's going to get added to every single page, regardless of whether or not it's needed. So this is a tool available in Drupal 7, and it's even more required in Drupal 8. The expectation now is that assets get attached to render arrays. So you only attach CSS and JavaScript to the elements that actually need them. CSS and JavaScript are meant to apply generally to elements of your page. The elements of the page get represented in Drupal as render arrays, so now we're attaching libraries to render arrays, so we're only loading the assets that we actually need. So when you have a lot of JavaScript and CSS, there are a couple of caching strategies, a couple of aggregation strategies you can use when you have a bunch of different files. You can serve all of those files individually. This is what happens if you uncheck that aggregate CSS or aggregate JavaScript checkbox in Drupal core. All of those JavaScript files and CSS from individual modules in your theme will get served individually. So each can be cached separately. So maybe you can bump up really high cache lifetimes and invalidate those caches individually, but you're going to have a ton of HTTP requests, and that could be a negative performance impact for your site. On the other end of the spectrum, you could package up all of your CSS and JavaScript into one and only one file per page. Now, the advantage here is you have only one HTTP request to get your CSS or JavaScript for every single page, but you might have poor caching because as you move around the site and different render arrays get added, different components, CSS or JavaScript files are needed, that one CSS or JavaScript file that's used on your page is going to be different across every page of the site. Or you could split the difference, which is basically the approach taken by Drupal core, where it will do some grouping. We saw earlier in that screenshot of Drupal.org, there were some aggregations of CSS and JavaScript, so it was serving less than if there had been no aggregation at all, but it wasn't getting it down to one file. The key question here, I think, is who owns this decision? How much time do you spend thinking about this decision? If you're using Drupal, Drupal has an answer. Drupal core has been handling this problem pretty well for a decade. We've had an answer to this question in Drupal core for a very long time. Some Drupal developers are starting to move the answer to this question into gulp or grunt, and I've done that on some sites. When I do that, when I take the decision of how CSS and JavaScript get aggregated and put together, when I take that decision away from Drupal and put it into gulp or grunt, now suddenly I own that decision, and I'm spending a lot more time than I would have had I just let Drupal handle it all. So suddenly I've made myself or my team a little bit slower because I'm suddenly worrying about something that I previously really didn't worry about at all. Maybe my site is getting faster by taking total control of my aggregation through gulp or grunt, but I've made my team a little bit slower. I've given my team one more thing to worry about over the lifetime of the project, one more thing to track across each different project. Our gulp and grunt files are a little bit different, whereas if we just let Drupal core handle it, it would be handled the same way. So another take on the question, why is the front end too slow? Maybe there are too many third-party widgets. Those third-party widgets like dropping YouTube videos in, or dropping those JavaScript-based share widgets, the Twitter share widget, the Facebook share widget. So what's the problem with dropping those all over your sites, those embed codes that you get from these popular services? Well, from the Google developer documentation, if the parser, if Chrome encounters a script tag in the middle of your HTML document, you're interrupting the conversation that the server was having with the client. The client had gotten that HTML document, it knew it had to parse a bunch of script tags in the header, then it thought, okay, I can just read an HTML document and understand it. Oh wait, in the middle there's another script tag and it's telling me to go over to twitter.com to grab this JS file. You've interrupted the conversation that the client was having. The client was trying to understand the document, but now you've told it, no, you actually have to go over to this other building, grab the JavaScript file, come back, parse it, understand it, and keep going with your conversation. That's kind of rude, but it's what happens a lot. So stats from about a year ago, how many files and what's the size of the payload coming from these share widgets from Google+, Facebook, Twitter, popular solutions. So Twitter is going to, as of a year ago, would add 4 files and 52 kilobytes in order to get that share widget. Why would you do that? So we have to keep asking why. Why are there too many third-party widgets on the site? I think one answer is often no one feels responsible for them. I've certainly gotten tickets as a developer saying, we need a share widget on the site. And I think, I hate share widgets. I personally don't use share widgets as a browser of the web, but I understand that a lot of stakeholders like share widgets. So I've gotten a ticket that says, we need a share widget. The stakeholder has said, hey, I did some Googling. I found this share widget. I really like the visual look. All you have to do is copy-paste the script tag, put it exactly where it's supposed to live in the HTML document, and I, as the stakeholder, will be happy. And it's very tempting as the developer to think, oh, this ticket that could take me a significant amount of time could only take me 15 minutes to copy-paste the script tag and put it where it's supposed to live. So who's really responsible then for that share widget? Am I, as the developer, responsible for how it was implemented? Is the stakeholder responsible for suggesting a visually pleasing but less performant solution? I think what we found here is an instance of Conway's law. Organizations that design systems are constrained to produce copies of the communication structures of these organizations. So if no one in your organization feels truly responsible for your social media strategy, if no one is responsible directly for the performance of the site, that organizational deficit is going to manifest itself in the website itself. A more direct example of Conway's law. Too many third-party widgets. Maybe there are 2 sets of analytics tracker codes. Maybe there are 3 sets of analytics tracker codes. Who's worked on a site that has used both Google Analytics and an additional tracking tool? Why? Sometimes the answer is because this marketing department likes Google Analytics, and this other department prefers Omniture or Chartbeat, and someone who no longer works here had a tool that they liked, and that's on the website. And we might need those stats at some point in time, so we're going to leave it on the site. If you as the developer are told the site is slow, we must make the site faster, and you start investigating and you find that one of the reasons your site is slow is because you're loading 3, 4 sets of tracking codes. And the reason you're loading 3 or 4 sets of tracking codes is because different factions in the organization have different reasons for adding these tracking codes, and they won't talk to one another. They don't even work in the same building. That's not a problem you as a developer can solve with a ticket. You can't get assigned a ticket and just fix that in an afternoon. That's an organizational problem that requires the whole team to work together. So when you're in a meeting with your team, are Are agenda items being added ad hoc? Are there factions who ignore one another? Do people interrupt each other in the middle of your meetings? Are you repeating topics from previous meetings that aren't even relevant to the meeting at hand? Are you starting your meetings late? If so, there's a good chance these problems will manifest themselves on the site. An organization which has that problem of meetings starting on time, that's an indication that this organization doesn't value people's time. If this organization doesn't value people's time, is this organization going to have the capacity and the discipline to evaluate the performance of the website? Is this organization going to care that it's making its users wait 3, 4, 5, 10 seconds in order for a website to load? If the organization really does care about people's time and cares that we're ready for our meetings, there's a good chance that will manifest itself in a website that is ready to tell the world immediately, here's our about page. This is what our organization is all about. So another take on the question of why is the website too slow? A new answer to this question is we don't have AMP yet. Accelerated mobile pages. That's why the front end of the site is too slow. So accelerated mobile pages is a new spec driven by Google and some other major players on the web, and it's a new way of delivering article pages in a much faster way. So if you Google for a news topic, like I imagine right now, if you Google for Brexit, the top of the Google search results would include little cards that give you AMP pages. And if you tap those AMP pages, you get a near instantaneous page load of the article. It's really, really impressive. But it feels familiar to me. So imagine it's 2004, and you've got a solid desktop site called example.com. Time moves forward. It's very easy to add new features, but removing features is really, really hard. Just like that CSS is sometimes hard to delete even if you don't need it. It's difficult to remove stuff. So by 2006, our desktop site has all these features, and we can't even keep track of them. It's just overflowing. So by 2008, this site that used to be good is just completely unusable on the new iPhone that's come out. So in 2008, the answer is, well, we just need a completely different site. We need m.example.com. We need a mobile optimized site. Moving forward in time, adding new features is still easy, and removing features is still hard. So these two sites, example.com and m.example.com, start to diverge with one another. By 2012, it's just unmaintainable, and responsive design is this new idea. So we make a new site. One site to rule them all. It works great on phones. It works great on the desktop, tablets. Everybody loves it. It's fast everywhere. Time moves forward. Adding new features is easy. Removing features is hard. And our responsive site that was pretty snappy on phones in 2012 isn't so fast anymore in 2014. It was mobile first in 2012, but mobile first is not mobile forever. The site is now too slow on phones, and AMP sounds like an answer. AMP is a way to get really fast performance for those articles on phones. And we now have two URLs. We have the default URL and the accelerated mobile page. The accelerated mobile page, and I guess the decelerated, slower default page. So we've solved the problem of too many features on our sites by adding another feature. And I don't know what else you could expect from that. My concern is that feature creep finds a way. Adding features is easy, removing features is hard. So to be clear, if you are a site owner and you have articles and they could benefit from having an AMP version, I think you absolutely should add AMP because it's amazing, it's so fast. Just know that it is not going to solve all of your problems. You're adding one more feature to your site. You're adding a feature that will make your site appear better in search results. It'll make your site much faster to load. However, it will not solve all the problems of your site. And I think moving forward, it could run into difficulty as well. So I think the question really with performance is how quickly can you get to a usable site? So I'm going to play this video that shows the big pipe module in Drupal 8. So this is a feature that has been added to Drupal 8.1 as an experimental module. And what BigPipe allows is for us to identify what are the fast areas of the site that can be served. What are the areas of the site that can be served instantaneously? The main content of the page can be served instantaneously for all users, whereas maybe those sidebars are customized per user, and those we need to load a little bit slower. So when we have that top level metadata, because we have the deep metadata, when we know what are the rules for caching these elements, we can get a much faster response. So how quickly can we get to a usable site? In order to answer that question, we need to get really specific about what our site is doing, what each element of our site is doing. And you're moving in the right direction when you can describe how the website is built. I mean this both in the long term, over that 2 or 3 month period that you're building the site. If you can describe verbally, clearly, how you go from that kickoff meeting that we heard about in project management and musical, how you go from that kickoff meeting to a fully built site, if you can explain that in a clear, concise way, there's a good chance that your resulting website is going to be fast. I also mean that at runtime. From the time a cold Drupal site is asked, prepare the about page, to the time it serves the HTML document, if you can explain, well, we're using core blocks, and the core block system has a small number of blocks. It asks each block, are you supposed to appear on the about page? The blocks that are supposed to appear on the about page render, and we serve the blocks along with the main page content. If you can explain that quickly, there's a good chance the site is going to be fast. If, however, the explanation of how is this site built is, well, we have context module that handles these pages, and we're using panels everywhere on these other pages, and we're using neither on these other pages. So, and actually on some pages we're using both page manager and context module. So, wait, what page were we talking about? I've worked on those sites, and they aren't fast. If we can't explain how the page is being built in real time, there's no way we can optimize how the page is getting built. If you can track changes over time, one of the things I'm excited about with making New Relic available to all Pantheon sites is you have the ability to mark deployments in time. So you can see we made a deployment last week, and we made a deployment on Tuesday, and on Tuesday the site got much slower. That gives you the ability to see and look, what changes did we make on Tuesday, what changes were deployed, how is that making our site slower, how can we possibly undo that, or how can we identify those kinds of changes in the future? Can we estimate in advance the performance impact of the site? If you can show your clients, you've made us add 2 carousels to the homepage already, and look, we have these graphs that show how much slower the site got with each carousel added to the homepage. They're asking us to add a 3rd carousel to the homepage. We don't expect the results to be good. You're moving in the right direction. If you can start a project with performance limits, if you can start a project by identifying, we're not going to make any users wait more than 2 seconds in order to get a usable page, and we want 90% of our users to not wait more than a single second. When you can make decisions that make your site faster and your team faster. You won't be able to make those kinds of decisions for every single topic, but the more decisions that you can make that make both your site and your team faster, the better off you'll be. And I think when performance is a boring topic, a lot of performance is often boring work of just asking yourselves, are we still using this CSS? Are we still using this JavaScript? Do we still need this module that we installed 3 years ago, played with, but maybe we didn't actually use for anything real? There still will be exciting new tools in performance. HTTP2 is a very exciting topic. I find BigPipe to be a very exciting topic, but the vast majority of performance work isn't all that exciting, and that's okay. So, thank you, everyone. Are there any questions?
So, a comment. Excellent.
Thank you. Thank you.
You mentioned midway through you were talking about ways to look at it from the client side. You said there was a once in a browser add-on module, whatever.
Oh yeah, the Chrome developer tools.
Profiler type thing. What was the name of that?
Sitespeed.io was the screenshot that I showed that had those.
It was earlier than that. You actually pointed like at the very bottom of the screenshot of the browser where a little window popped up saying which how many.
Web Profiler, which is now a part of the Devel package in Drupal 8. I think in Drupal 7 it's a standalone module. There we go. Yeah. So develop module as well, just plain old develop module gives you similar things. I just like the visual look of this. You can click on the database queries and actually just get a list of all the queries. Yeah, I find it really helpful. All right. Well, thank you, everyone.